We have sent probes across the solar system, but the places still beat us every time. Pluto and Proxima Centauri. For more than 60 years, humans have sent spacecraft to almost every major corner of our solar system. We have studied the Sun up close, visited Jupiter's storm, and even flown beyond the orbit of Neptune. But the two places still stand as our greatest challenges. Pluto, the frozen world at the edge of sunlight, and Proxima Centauri, the nearest star outside our solar system. Why are these two destinations so difficult? The answer is surprisingly simple. Speed is easy, stopping is not. The dream of reaching Pluto. For decades, Pluto felt like a myth. It sits more than 6 billion kilometers away. So far that sunlight takes over 5 hours to reach it. NASA documents and research from Johns Hopkins Applied Physics Laboratory (APL) show that missions to Pluto needed perfect timing and extreme speed. The Grand Tour opportunity. In the 1970s, scientists found a real alignment of planets, something that only happened once every 176 years. This alignment would allow a spacecraft to use gravity like a slingshot and travel faster than ever before. This was the idea behind the Grand Tour mission, which later created Voyager 1 and Voyager 2. NASA actually considered sending Voyager 1 to Pluto, but scientists chose to send it toward Titan, Saturn's moon, because studies by the Jet Propulsion Laboratory (JPL) showed Titan could support complex chemistry similar to early Earth. That choice meant Pluto would have to wait. New Horizons, the fastest trip ever. After many failed proposals, a small team led by planetary scientist Dr. Alan Stern pushes for a new mission. In 2006, NASA launched New Horizons, one of the fastest spacecraft ever built. According to NASA's mission data, it left Earth at over 49,000 km per hour. Even at that record-breaking speed, the journey took 9.5 years. When New Horizons finally reached Pluto in 2015, it could not stop. It was not designed to. According to APL engineers, stopping would have required so much fuel that the spacecraft would have needed to be thousands of kilograms heavier. So it performed a flyby, capturing the first clear images of Pluto. Nitrogen ice plains, icy mountains, thin blue atmosphere, the famous heart-shaped region. Those images changes how we understand the outer solar system forever. Why stopping is harder than going? Here is the real challenge. The faster a spacecraft travels, the harder it becomes to slow down. Research from NASA and ESA explain that even a small deceleration in deep space requires massive fuel. Solar power does not work well at Pluto's distance. Sunlight is too weak. That means missions need radioisotopes power, which is limited and expensive. So, New Horizons did the only thing possible. It flew past Pluto and kept going. Proxima Centauri, our nearest but most impossible target. Now, imagine traveling not billions but trillions of kilometers. Proxima Centauri is 4.24 light years away, around 40 trillion kilometers. At Voyager 1's speed, data from NASA Heliosphere mission shows the trip would take over 70,000 years, even if we somehow speed up the spacecraft. At 1% of the speed of light, the trip takes 400 years. At 10% of the speed of light, the trip takes 40 years. But there is a huge problem. How do you stop a spacecraft moving even a few percent of the speed of light? Has the kinetic energy of thousands of nuclear bombs. Slowing it down would require fuel we cannot carry from Earth. This is the same issue we face with Pluto, but a million times larger. New technologies, research-based, scientists around the world are working on solutions. Number 1. Ion engines. Used by NASA's Dawn mission, proven to accelerate slowly but efficiently for years. Still too slow for interstellar travel. Second, Bessemer plasma engine. Developed by astronaut Franklin Chang Diaz, could shorten Mars travel from months to weeks, but Proxima is still centuries away. Third one, solar cells. Proven by JAXA Icarus mission, uses sunlight pressure to move, reaching another star thousands of years. Fourth one, laser cells. Breakthrough Starshot. Supported by scientists like Stephen Hawking and funded by the Breakthrough Foundation. Use Earth-based laser to push tiny spacecraft to 20% of the speed of light. Travel time to Proxima 20 to 30 years. But again, the same limitation. They can't stop when they arrive. The human story. Even if our probes never returns, they still carry our curiosity into the universe. Voyager still sends faint signals from interstellar space. New Horizons drifts beyond Pluto, still exploring the Kuiper belt. Future laser cell probes may race past Proxima, giving us our first glimpse to another star approach. Pluto shows us how far we have come. Proxima shows us how far we still need to go. Humanity stands at the very beginning of the space age, the slowest century of exploration. But each launch, each probe, each silent signal in the dark tells the same story. We are here, we are learning, and we are not stopping. If you could choose only one destination, Pluto's frozen heart or Proxima Centauri, the unknown world around our nearest star, tell me your answer in the comment. Like the video if you love space mysteries and subscribe to Pulsar Lab for more journey beyond the known universe.